Hello, I'm Mike Walker. I've been working around SMI for about 20 years in various capacities, including authoring parts of SMI-S. I'm retired now, but I worked for the IBM Corporation for 38 years, which is where I got involved with the SNIA and SMI-S. Most recently, I've been working with a Python package called PyWBEM. PyWBEM provides client software for accessing WBEM servers like SMI-S 1.8.0 servers. PyWBEM isn't the only tool you can get to work with WBEM servers, but it is a tool that is actively being maintained. Today, I'll be talking about simplifying client interactions with SMI-S using PyWBEM. So let's get to it. I use mock servers for the purpose of illustrating client interactions. This allows me to mock an SMI-S 1.8.0 server without having access to the actual 1.8.0 enabled storage device. Before we get into simplifying client interactions with SMI-S, there are a few things to know about PyWBEM. First, PyWBEM and PyWBEM tools are Python packages that provide access to WBEM servers. PyWBEM provides a Python API for accessing WBEM servers. PyWBEM tools includes a command line interface for accessing WBEM servers via the command line prompts. Both these interfaces simplify access to WBEM servers. Both PyWBEM and PyWBEM tools are actively being maintained. I created my mocks using Python 3.6.5, PyWBEM 1.1.1, PyWBEM tools 0.8.0. All three have been upgraded since the mocks were created. Python is now at 3.9.6. PyWBEM has moved to 1.2.0, and PyWBEM tools has moved to 0.9.0. Both these packages support mechanisms for mocking WBEM servers, including SMI-S servers. So a mock server may be accessed by either PyWBEM or PyWBEM tools. Mock servers can be extremely useful for developing applications or scripts or tools on your local system. My work on creating mocks of SMI-S 1.8.0 and scripts for illustrating its features triggered several enhancements into both PyWBEM and PyWBEM tools. If you're familiar with Github, it's a relatively easy thing to do. I simply logged an issue against PyWBEM tools, and the development team would propose a fix using pull requests. So let's talk about uses of mock servers. SMI-S 1.8 is the latest release of SMI-S. As a result, there aren't that many implementations in the field yet. A mock server can be useful to explore features that are new in SMI-S 1.8. For example, mock servers can be created to support the WBEM server profile and advanced performance metrics for arrays. Both are new features in SMI-S 1.8. My mocks were set up so I could illustrate some of the new features in SMI-S 1.8. Mock servers can be used to develop tools and scripts to be used with SMI-S servers using either the command line interface or the PyWBEM API. Command scripts I developed illustrate how to find useful information in SMI-S 1.8 servers. I call them quick start guides. They are intended to help IT professionals find various types of information in an SMI-S server. Mock servers can be used to develop client software using the PyWBEM API. For example, I used Python and PyWBEM to build the tools for creating my mocks. Finally, mock servers can be used as a local test environment for testing tools and applications. To test any PyWBEM application or tool, a WBEM server is required. So a mock server is a good way to establish a test environment. To assist folks that might be interested in working with mock servers, I've created a public GitHub repository of SMI-S 1.8.0 mock servers. It can be found on the following link: github.com/farmermike252/SMIS_mocks. These mock servers were developed to illustrate new features in SMI-S 1.8.0, which is now an ISO standard. The ISO standard can be found at iso.org/search.html Q = 24775. Finally, the GitHub repository includes a directory of quick start guides. These guides are designed to help IT users find useful information, such as hardware, product, software, capacity, and performance information in an SMI-S server. These guides are PyWBEM CLI command line scripts to access WBEM servers. The scripts work on the array mock server. These guides are illustrated in videos on the SNIA PyWBEM page at the following address: http://www.snia.org/PyWBEM. The Quick Start Guides folder also contains the presentation in the installation and setup video for installing Python, virtual environments, PyWBEM, and PyWBEM tools. The presentation tells you where to find Python. It's to download and install. It also provides pip installable versions of virtual environments, PyWBEM, and PyWBEM tools. When you go to the GitHub page for the SMI-S mocks servers, this is the page that you will see. There are directories for each of the mock servers and a directory for the quick start guide scripts. The array mock directory contains 3 files that make up the mockup of an SMI-S 1.8.0 array. The NAS head mock directory contains 3 files that make up the mockup of a SMI-S 1.8.0 NAS head. I will talk about the 3 files later. The Quick Start Guide directory contains PDFs. If you look at the Quick Start Guides directory, there are PDFs for each of the guides, and there's a PDF describing the pip installation and setup of the required Python packages. The QSG files show commands to use to find things, the output when run against the array mock, and text explaining both the commands and the output. The PDF PyWBEM pip installation and setup right here is a PowerPoint presentation on how to install release software for each of the programs and packages that you will need to run PyWBEM and PyWBEM tools. The ISO standard page shows 8 documents that can constitute SMI-S 1.8.0. The screenshot only shows 2 of the parts of SMI-S, the media libraries, and host element parts. But there are 6 other parts on the page. When you go to the SNIA PyWBEM page, you can find links to my YouTube videos illustrating the quick start guides. They are at the bottom of the page, so you'll have to scroll down the page to see the screenshot I'm showing. The videos actually show each of the quick start guides. The videos take you through the information we're looking for, explain the commands, execute them, and get the output and explain what the output tells us. Using the mock servers. So feel free to use the mock servers in the GitHub library. They may not contain everything you might want or need, but it might help you get started, and the mocks can be expanded over time. You can download the individual mocks or clone the whole repository. Each mock is made up of 3 files. A leaflist.xml file, which defines the classes or moffs be loaded into the mock server. The classes are the classes defined in SMI-S 1.8.0 for the profile being mocked. An instance moff file that contains instances to be loaded into the mock server. The instances are instance moffs for classes used to describe the contents of the device being mocked. A mock load program, a Python program that performs the loading of the classes and instances. This is a Python program that reads the leaf list file and the instance moff file and loads them into the mock server. Assuming you are using virtual environments, these files need to be copied into your virtual environment working directory. Well, I hope you found this presentation useful. I certainly hope you did. And if you have any comments or questions, we'll be glad to take them. And thanks again for giving us your time.